Hi, I'm Rahul Nair from the Windows Performance team, and this video is about understanding pool usage using the Windows Performance Analyzer. The first part of this video will introduce the basic concepts about pool, then I'll go into a demo of collecting and analyzing some pool data, and close with some guidance and best practices on how to reduce pool usage. Let's start with some basics. At system initialization, the Windows Memory Manager creates dynamically sized pools of memory that kernel mode components and device drivers can use to allocate memory. Pool usage represents a significant percentage of the memory usage of a system, and any reduction in pool usage will reduce the overall memory usage of the system. This is an area that we've actively invested in during the course of Windows 8 to reduce memory usage, and we want to enable driver developers to do the same for their drivers. The Windows pool has four basic allocation areas. Non-page pool, which contains allocations that are guaranteed to reside in memory. Page pool, which contains allocations that can be paged out of memory and to the page file. Paged pool allocations are by default non-executable. In Windows 8, we've introduced a new type of pool that provides the same non-executable protection for non-page pool allocations, the NX non-page pool. Then there's session pool, which contains allocations that are made per session. These are primarily graphics related and also for drivers that are shared across sessions, like your keyboard and mouse driver. Now let's talk about how to collect and analyze pool data. Let's start with some vocabulary. There's some general classification information based on the type of allocation, for example paged or non-page pool. There's some basic data like the size and lifetime of a particular allocation, the stack or function responsible for it, etc. There's some metadata that's specific to pool allocations, for example, pool tag, which is a 4-character label which helps us uniquely identify a particular pool allocation. There's also some context data that helps identify whether a particular allocation was transient or short-lived, and also whether a particular allocation was alive or outstanding at a given point in time. Let's see how we can collect a pool trace. We have instrumentation in the OS that enables us to gather data on every pool allocation that happens on the system. Pool data is collected system-wide and is not restricted to a particular driver or process. To collect a pool trace, open the Windows Performance Recorder UI, select your target application as the entire system, select pool usage from the list of memory profiles, select your scenario of interest. If you're a boot start driver, you might want to select an on-off scenario, click on Start to start tracing, and Save to save the trace when done. The Windows Performance Analyzer provides 4 graphs for pool, 2 showing the cumulative size and number of allocations, and 2 showing the same for allocations that are outstanding at a given point in time. You can use these graphs to visually understand pool usage over time and also drill down on specific areas for analysis. As you can see, there are multiple lines in each graph, each correspond to a particular pool tag. Apart from these graphical views, the raw data is exposed via summary tables. The data in the summary table can be aggregated in different ways. For example, as you see from the image, everything to the left of the gold bar is aggregated. You can aggregate based on paged versus non-page pool. You can aggregate based on a particular driver name. You can also aggregate based on pool tag. What this allows you to do is get more insight from the data. If you select a particular region from the visible portion of the trace, the allocations that were made in that particular region gets highlighted in the summary table. The summary table also provides some context information regarding whether an allocation was made or freed within the visible portion of the trace. Now let's move on to actually seeing the tool in action. This is WPA. I've opened up a pool trace that I had collected a little while ago on my machine. As you can see, on the left there's a grouping for memory. If you open that up, you would see the 4 pool graphs that I had mentioned earlier in my presentation. Make sure you've loaded symbols prior to doing any analysis. This will make sure that you have symbols corresponding to your stacks while you're drilling deeper into the trace. On the right hand side, there's an analysis view where you can do detailed analysis. For more basics on how to use WPA, there will be more reference material available. On this particular demo, I'm just focusing on pool. So drag one of these pool allocation graphs to the right. For this particular demo, I've chosen cumulative size by paged. Each of these lines in the graph, as I had mentioned earlier, correspond to a particular pool tag. If you hover over one of these, you would know the pool tag and also the type of allocation. So in this case, it's CM31 and it's a paged allocation. If you're a driver developer, you're more interested in finding out the allocations from your particular driver. So on the top right corner, click on this button to enable Summary Table View. This is the Summary Table View. Everything to the left of the gold bar, as I had mentioned earlier, is aggregated together. So I want to drill down to allocations made by my particular driver. Right-click on the Summary Table to enable Column Chooser. Select Pool Tag Module. Once you have Pool Tag Module, drag that all the way to the left to aggregate based on driver name. So I have a test driver for this trace that I want to analyze, mmtestdrv.sys. If you click on mmtestdrv, the graph filters to just showing the allocations made by my particular driver. As you can see, there are some interesting patterns in which my outstanding allocations seem to be growing over time. I want to see what these allocations are. Open up mmtestdrv. That shows you that I have paged allocations as well as non-paged allocations. Let's focus on non-paged allocations first. Interestingly enough, I have a pool tag called leak, which is allocated 10 times for a total of 10 megabytes. I want to see the stack corresponding to this particular allocation. So I move stack to the left, I open up stack, and this shows me the exact stack where this particular allocation took place. And all of these took place from the same stack. Now I want to look at my paged allocations. So if you open up paged, you can see that my driver has 3 pool tags which are allocating page pool. And of those, leak seems to be the biggest with about 40 megabytes allocated. So I want to see where this comes from. You can open stack again and see the function corresponding to this particular allocation. Now there are some questions that you can ask based on the allocation patterns that you see here. Why are my allocations increasing over time? And why is my outstanding higher at the end of this pool trace? Can I free any of these allocations before the end of the trace? Is this a memory leak where I'm forgetting to free something that I've allocated? There are multiple questions that you can ask based on this particular trace and looking at the function which allocated this particular pool allocation. This is just basics on how to look at pool allocations for your driver. I would encourage you to experiment with the columns on the left side and aggregate and group in different ways to understand the pool usage of your driver. Now that you've seen the capabilities of the tools, let's talk about some guidance and best practices on how to optimize pool usage. Focus on your most important user scenarios. Understand them from the perspective of your transient or short-lived allocations and also from the perspective of your persistent steady-state usage. Pool is a shared memory resource. You have to be economical with how much you use. Most importantly, minimize your non-paged usage. This includes your non-page pool allocations, MDL allocations, and also your non-paged code in memory. Secondly, understand your allocation patterns. Ensure that you free allocations as soon as possible. Be judicious and avoid excessive pre-allocations. Separate your long-lived and short-lived allocations, as intermingling them can result in fragmentation. And finally, move your non-page pool allocations to the more secure NX non-page pool. To conclude, pool represents a significant percentage of the memory usage of the system, and any effort to reduce pool usage will reduce the overall memory usage of the system. We want to encourage and enable driver developers to utilize these tools and actively invest in optimizing their memory usage. Thank you.